everyone, and welcome to my talk, Harnessing the Power of ZIO Schema. So some time ago, I got into technical discussion online, and the guy was asking an interesting question. He was asking, how do you generate code? Do you just append strings? And so it was a Java dev, and discussion went on, and then after 50 of comments, someone pointed him to metaprogramming in Rust, and then to macros in Scala. But essentially, his problem was that he wanted to generate some boilerplate code based on the structure of his data. So today, I'm going to talk more about this. I call it the boilerplate problem, the one that this guy had. And we'll see macros in action. So we'll talk about macros and see if they can help us, or if they also have some drawbacks. Then I'll introduce ZIO Schema, and I'll show you how I use ZIO Schema in my open source work. And at the end, I'll show you how you could use ZIO Schema for your daily job in your client projects. So basically, nowadays, programming languages are pretty good at handling boilerplate. We have type classes, we have parametric polymorphism, functions, traits, so we can abstract over the code. But there is one specific type of boilerplate that is pretty hard to handle, and that is boilerplate that depends on the structure of your data. So let me give you a couple of examples. So let's say you are writing property-based tests, and you have some data type, like an event, and you want to generate some event for your test. Now, you don't care about specific UUIDs or strings as far as the types match. But to write this is quite boring and boilerplatey. At the same time, when you have like different layers in your application, you would like to translate even DTO into event. And even though they contain the same data, more or less, compiler has no idea that these data types are the same. For compiler, these data types are completely different. What about some other examples? So in general, one bucket of boilerplate examples is to generate data from schema. So let's say we have microservices, and we describe a service with protobuf, and we would like to generate some interface to call from other service. Or on the other hand, we would like to generate schema from data. So let's say we have ZIO HTTP, and we would like to generate, because the endpoints descriptions in ZIO HTTP, they form pure data. So it's possible to generate open API out of this data. Another class of problems is type class derivation. So like if you want to generate ordering for an event based on every field of this data type, that's quite boilerplatey. And also the validation in general, like we have lots of fields which are lists, and we want to validate if they are not empty. So that's also boilerplatey. So Scala programming languages offers built-in solutions in the form of macros. So basically, when compiler compiles your code, it takes your code at the beginning and produces bytecode at the end. And at some stage where compiler is processing the macros, it sees your code as a typed abstract syntax tree, which is like a tree-like data structure. And this tree-like data structure, you can pattern match, inspect, and based on it, you can generate some more code. So let's take a look at some macro example, just to get a feel of it. So this example is taking some type, some value of some type, and if it's list, then it orders this list. If it's set, it just returns the set, and otherwise fails with compile time error. Now there are two things to note here. So first thing is that we have these quotes and splices. And so in order to be able to write code like this, you need to understand that basically you have two different execution environments. So compile time executed in compiler and runtime. So that's one thing. And the other thing is this explicit summoning of ordering T type class. So basically, if this was a normal code, you don't have to use on line 27 using, because compiler would just find the ordering T instance of ordering T type class. But here, the problem is that compiler first processes a macro, and then it expands it to the call site, and then it processes the call site. So what it means in practice is that compiler has no idea that T is int or string at call site. And so this example, without using on line 27, would fail, saying that compiler cannot find instance of ordering type class. So you might be wondering why I'm telling you all this stuff. So basically, the point I'm trying to make is that macros are not code as any other. So this is not something, what I just tell you, this is not something I want to teach my colleagues, and this is not something I even want to remember, to be honest. So in general, I think the biggest drawback is that it's hard to introduce macros to clients project. I cannot imagine going to my boss and say, hey, let's introduce some macros. I will be the only one that can maintain it, and it's going to bottleneck on me, and if I'm left, then you're going to rewrite it. So I think that's like the biggest drawback, but also you need to be explicitly trained in macros. But in general, the problem that we're trying to solve here is that we are trying to generate some boilerplate code based on structure of our data. So if we had structure of our data stored as a value, maybe we could come up with a simpler solution which doesn't have all these drawbacks, but also is not powerful as macros are. But maybe we don't need all that power all the time. So this is naturally introducing us ZIO Schema. This is exactly the place where library like ZIO Schema can help us. So let me first do like an introduction to ZIO Schema. So ZIO Schema 101. So let's say we have some case class person, which is, it's like a compile time construct. So in order to reify it, in order to turn this into a value, we would have to describe its structure. So simple possible schema for a person would look like this. So we have a case class with 3 type parameters. So A1 is the type of, in case of person, of string. A2 is the type of int. Z is the type of person. We have a name of case class. It's fields. Field remembers to which case class it belongs to. And field also has its name and then a primitive type. So in this case, it's only string type or int type. And this is how it looks like when we create an instance of this case class. So all the things I just talked about, the name is person. We have a field 1, field 2, apply constructs the person, and unapply deconstructs the person. So let me show you how I use ZIO Schema in some open source work. So first example is, let's say we want to write some SQL migration script. So let's say we have a customer table in SQL, and these columns are described by customer case class. And so after some time, we decided that we don't really want to know the age of the customer, but we would like to know if the customer is verified. So we would like to, based on a diff of these 2 case classes, generate a SQL migration script, as you can see at the right-hand side. So first thing we need is the schemas for customer 1 and customer 2. And then we can derive, or we can call migration derive to get the chunk of migrations. And essentially, it's like a list of steps that you need to take in order to get from customer 1 to customer 2. Now, migration is ADT that has a bunch of constructors, so you can collect, it's like a map with filter. We only care in this case about add node and delete node constructors. And in these nodes, we have all the informations we need. So in order to write that SQL script that you have in a comment, we would need to access the name of the table. That's like the name of the whole customer schema. And then we have their field name in the field schema. Field type name is like a helper method that I'm not showing here, but also it's very easy to find the type of the schema from if you have from the field if you have a schema of that field. And also every schema has a so-called default value. So in this case, verified is a Boolean, so default value is false. And in the case of a delete node, it's even simpler because we have the name of the table and we have the name of the column. So I said that ZIO Schema is less powerful than macros, and mostly because you cannot execute code at compile time, but still you can do some compile time verification. So let's take a look here. So let's say we wanna implement such a DSL as you can see down there. So insert SQL DSL. We would like to do insert into input like a users table, and then specify a list of values. So if you take a look at the users table type description and the schema for users, you could see that we have very similar information there, and all these informations are there at compile time. So if we go to implement insert into, then we get to the values method, and there we have just a list of A's, and we know nothing about the A's. So we can implicitly summon the schema of A, and then we can summon one more sealed trait called valid insert, where we will stick A and columns. So on this next slide, you could see in the comments, so what is columns? Columns is this intersection type of the tuple of a singleton type of field name and the field type. And then schema of A is this schema case class 3. So now this valid insert is sealed, so you are in control of creating instances of this valid insert. And with a bit of imagination, you can see that we could create instance of valid insert only in case this schema of A and columns match. So we could use these called runtime proofs, this stuff there, but it's basically just also another implicit. So one more thing I wanted to show is dynamic value that I also used. And dynamic value is interesting because it combines values together with its structure. So going further with this insert example, we would like to translate the insert data type into actual SQL query string. So we're trying to implement the render method. Now the render method, the first part is easy because we have insert data type that holds the table and also holds the column names. But the interesting problem is when you're trying to render values, because values are again just some list of A's or just A. And even though we have a schema of A, there's no really way to peel off some data from A. So let's see how this render values is implemented. And basically, you can turn value of A into so-called dynamic value by calling schema to dynamic. And dynamic value is, again, ADT that has a bunch of constructors. So it's either record, tuple, enum, and you can pattern match on it. And like in this case, if it's a record, you can recurse. If it's primitive, then that you render. Yeah, I didn't show the whole example on this slide, but based on what type of SQL you are dealing with, you can render differently Booleans or strings or ints. but you already know like what kind of value am I dealing with at this point. So if you introduce ZIO Schema to your project like today, then right away you can gain some benefits. I just took like 4 examples to show you. So this example from the beginning, you can, in order to generate some event, you can just write derive gen event, but somewhere in the scope you need to have implicit value for a schema of gen in order for this to work. Another example built on top of the previous one, like let's say you want to sort this generated list of events. Every schema has an ordering built in, so you can just call sorted with the schema.ordering. So you can also do the validation of data. Now in this case, I used annotations to show you how you can annotate your fields in your data. But if you don't like annotations, I completely understand. You can also stick your validations inside the schema itself, but you would have to write your schema manually. And now that schema has validations inside it, you can use schema to validate instance of your data type. And the last example, I just found this in docs, and I found it really cool. I called it like the derived serialization. And it means that we have some JSON, and we're trying to serialize it into data type that has a different structure than this JSON. And we can do that because like person DTO describes this JSON directly, but the schema of a person is transformed from schema DTO. So like inside that transformation, first name and last name is concatenated into a name. And then when you serialize this JSON to the person directly, it just works because that's how schema is done under the hood. All right, so every time when you are facing a problem and you feel like your programming language isn't strong enough to describe solution to this problem, maybe it's time to take a look at macros, but they have some drawbacks. And I think ZIO Schema could really help you, so I encourage everyone to take a look at the docs more. Repository contains a lot of other interesting examples, and all the code that I showed you today is on my GitHub, so you can check that as well. Thank you very much.